in this lecture we will find out the area of square ABCD. In the drawing we have square ABCD. You know that BP equals to 5 units in its length. This is angle BDP is equals to 30 degrees in its size. This is angle PBC is also equals to 30 degrees in its size. DB is the diagonal of this square ABCD. Again, our task is to find out the area of this square ABCD. So, the diagonal of a square bisects the angles of the square. So, DB bisects angle ABC. So, this angle equals to 45 degrees in size in total. But this angle equals to 30 degrees, and therefore the missing angle must be equal to 15 degrees in its size, because 15 plus 30 degrees is 45 degrees. So this angle is equal to 15 degrees in its size. So in triangle BDP, this angle equals to 15 degrees. This angle equals to 30 degrees. 15 degrees plus 30 degrees is 45 degrees. And therefore, this third missing angle must be equal to 135 degrees in its size. According to the rule that says that the sum of the angles in any triangle is equal to 180 degrees. So here we can implement the law of sines. Please click on the law of sines. The law of sines is true in any triangle. Triangle ABC could be any triangle. Side AB equals to C units in its length. Side AC equals to B units in its length. Side BC equals to A units in its length. This is again BAC. This equals to 80 degrees inside. This is again ACB equals to C degrees in size. This is again ABC is equals to B degrees in size. So in this triangle ABC that could be any triangle, the following equation is true. That A over sinus A equals to B over sinus B equals to C over sinus C. Again, this is side A over sinus A equals to B over sinus B equals to C over sinus C. So we can implement the law of sines in our drawing. In our drawing we get that 5 over sinus 30 degrees the law of sines. We get that 5 over sinus 30 degrees is equal to dB over sinus equals to dB, side dB over sinus 135 degrees. So again, according to the law of sines, we triangle DBP we get 5 over sinus 30 degrees equals to dB over sinus 135 degrees. So in the next step, we define side AB of this triangle on this square ABCD. This side AB is x, therefore side AD must be also equal to x, because all the sides of the square are equal to each other. So in the big triangle ABD, this angle equals to 90 degrees in its size. In the big triangle ABD, x squared plus x squared equals to BD squared. Again, in the big triangle ABD, x squared plus x squared equals to BD squared. X squared plus x squared is 2x squared, so 2x squared equals to BD squared. Here you take out all of this equation and finally get that BD, the opponent's BD, is equal to the square root of 2 times x. The opponent's BD equals to the square root of 2 times x, according to the Pythagoras theorem. So if you know that the triangle DP 5 over 30 degrees equals to DB over 135 degrees. And we just right now found out that DB equals to the square root of 2 times x. So we substitute dB by square root of 2 times x and we get that 5 over sinus 30 degrees equals to dB is square root of 2 times x over sinus 135 degrees. Again, I should found out that 5 over sinus 30 degrees equals to the square root of 2 times x over sinus 135 degrees. So we have 5 over sinus 30 degrees. Sinus 30 degrees is 1/2, and it equals to square root of 2 times x. X is one side, the length of one side of square ABCD. So the square root of 2 times x times sinus 135 degrees. Sinus 135 degrees is equal to the square root of 2 times 2. So today we found out that 5 over 1/2 equals to the square root of 2 over square root of 2 times 2. 5 over 1/2 equals to 10. And 10 equals to, here we will move 2 to the numerator and square root of 2 to the denominator of this expression. We get that 2 times x over square root of 2 times 2. So 10 equals to square root of 2 times x times 2 over square root of 2. Here square root of 2 in the numerator, square root of 2 in the denominator, so square root of 2 will get cancelled, and we have to leave 10 is equals to 2x. 10 equals to 2x, we will divide this equation by 2 and finally get that x equals to 10 over 2 is 5. So the length of one side of square ABCD is equal to 5 units. We know that the area of any square is equal to the length of one side squared. So the area of square ABCD must be equal to the length of one side, so the side AB, and AB equals to x, and x equals to 5. So AB equals to 5, so it is 5 squared. The length of side AB squared. 5 squared is 25. So in total we found out that the area of square ABCD is equal to 25 square units in its size. So the answer to the question is that the area of this square ABCD is equal to 25 square units in size. So the next step I will summarize the lecture. Our task in this lecture is to find out the area of this square ABCD. The one we have DB is the diagonal of this square ABCD. Know that this is angle PD is equals to 30 degrees inside. This is angle PBC is equals to 30 degrees inside. PB equals to 5. Our task is to find out the area of this square ABCD. First of all, we define side AD is x, side AB is also x. And then we implemented the Pythagoras theorem of this triangle ABD. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So in the right triangle ABD, x squared plus x squared equals to db squared. Again, x squared plus x squared equals to db squared. X squared plus x squared is 2x squared, so 2x squared equals to bd squared. So here we took out all those equations and found out that the missing hypotenuse BD is equal to the square root of 2 and times the square root of x squared is x. So in total dB equals to the square root of 2 times x units in its name. So here we focus on triangle DBP. Here we can implement the law of sines in the triangle DBP. According to the law of sines, the triangle, the law of sines is called any triangle. This is a triangle ABC that could be any triangle. Side AB equals to C units in its length, side AC equals to B units in its length, side BC equals to A units in its length. This is angle BAC, this is equals to 8 degrees inside. This is angle ACB, this is equals to 6 degrees inside. This is angle ABC, this is equals to B degrees in its size. According to the law of sines, the following equation is true. That A, this is the length of side BC, this is A over sinus A equals to B over sinus B equals to C over sinus C. Again, A over sinus A equals to B over sinus B equals to C over sinus C. So we can implement the law of sines in our drawing. According to the law of sines, we get that this triangle DBP square root of 2 times x over sinus 135 degrees equals to 5 over square root of 30 degrees. So again, according to the law of sines in this triangle BDP, the following equation is true that square root of 2 times x over sinus 135 degrees equals to 5 over sinus 30 degrees. And again, according to the law of sines in triangle BDP, the following equation is true that 5 over square root of 30 degrees equals to the square root of 2x over sinus 135 degrees. And 5 over sinus 30 degrees equals to the square root of 2 times x over sinus 135 degrees. Sinus 30 degrees is 1 half, so this side of the equation we have 5 over 1 half, and it equals to square root of 2 times x over sinus 135 degrees. Sinus 135 degrees equals to the square root of 2 times the square root of 2 over 2. So in total, we found out that 5 over 1 half equals to the square root of 2 times x over square root of 2 over 2. Here we have 5 over 1 half is 10. Here we have square root of 2 times x over square root of 2 over 2. So 2 we remove 2 to the numerator and square root of 2 to the denominator here. And we get in total that 10 equals to the square root of 2 times x times 2 over square root of 2. We have square root of 2 in the numerator, square root of 2 in the denominator, so square root of 2 will get cancelled, and finally we get that 10 equals to 2x. 10 equals to 2x. Here we divided the equation by 2 and finally found out that x, that is the length of one side of square ABCD, is equal to 10 over 2 is 5. So the length of one side of square ABCD is equal to 5 units, and therefore the area of square ABCD, that is the there are the solution for this question. It is equal to the length of one side squared. This is to say, it is equal to 5 squared. 5 squared is 25. So if you found out that the area of this square ABCD is equal to 25 squared in size. Okay, thank you very much.